Advent of Code Day 11. Let's get into it. So, sorry, I'm a couple seconds late here getting started, but let me turn my fans off. Just getting my files up here. Going to be day 11 down here. All right. So I did actually uninstall IntelliJ version 24.3. I got tired of it hanging all the time. It was really getting annoying. First, let me just see what my input looks like. Okay. Okay, initial arrangement. Is this my test input? And if so, yeah. All right. What does this mean? Okay. Ancient civilization on Pluto, known for its ability to manipulate space-time, while the historians explore blah, blah, blah. At first glance, they seem like normal stones. They're arranged in a perfectly straight line. Each stone is a number engraved. Strange part is that every time you blink, the stone change. Sometimes the number engraved on a stone changes. Other times a stone might split in two, causing all the other stones to shift over a bit. Okay. As you observe them for a while, you find that stones have a consistent behavior. Every time you blink, stones each simultaneously change according to the first rule in this list. So, if a stone is engraved with the number 0, it is replaced by the stone number 1. Stone is engraved with a number that has an even number of digits. We are heading for an LCD part 2. I can feel it coming. Stone is engraved with an even number. It is replaced by 2 stones. The left half of the digits. Okay, number of digits. I see. 10 is 0. Okay. None of the other rules apply. The stone is replaced by a new stone. The old stone's number multiplied by 24 is engraved in the new stone. Okay. So this is some kind of counter of some form. All right. So input's easy enough to read. It's actually just dot trim dot split dot map it to int. These inputs are all ints. I'm going to switch them to long because I can just tell that that is coming. I'm just going to represent them as long. Okay. And this is my, these are my stones. And I know I'm going to need to mutate this list, so let's do 2 mutable lists. Actually, no, let's not do 2 mutable lists because I want to do copies, so let's do 2 mutable list as the input to this function. Okay, and so, in this example, after blinking, you would have that many stones. Okay. How many stones would you have after blinking 25 times? I have a feeling that what I actually need to do is figure out the real pattern that's happening here. Because I think the numbers aren't going to matter. I think what is going to happen is I'm going to need to notice, for instance, a stone is 0, it becomes 1. So it goes from even to odd, but it doesn't change the number of stones. The only thing that changes the number of stones is every even number. And so actually what I think is happening. Okay, yeah, there's a trick. There's a trick. Right out of the gate, there's a trick. I am trying to figure out how many stones there are. Right? So I don't actually care what the values are. It's irrelevant. Because what I actually want is to just get the total number of stones. And the thing I know about the total number of stones. Oh no, the actual number does matter because of the way I split. Ah, that's clever. Cats, if you keep fighting, I'm going to be very upset. I'm not dealing with fighting. Never mind. I was getting excited because I thought I figured out a trick, and I didn't because of the way you split it in half here. Because the problem is it matters if, like, if this is 1100, then we have an odd number and an even number. Oh, wait, no, it's just the number of digits then, right? Yeah, the something about this 2024 makes me want to think that there's a trick here that involves binary, but let's just do the dumb approach. Okay, so and this is going to be int blink count, and so let's just to test this, we're going to try first 6 blinks. Oh, sorry, I did a Java. Okay. So from there, it's going to be, and this I want this to be a linked list, actually. Um, this is a case where I actually want a linked list because I'm going to be stepping through and doing inserts in the middle. And so if I'm doing inserts in the middle, that's going to be beneficial to handle that, I think. So um, actually, no, I don't want it to be a linked list because I'm just going to trade off memory for runtime. Right, let me actually like try solving the problem instead of thinking about the best way to solve the problem. This is what I get stuck doing is I just think like too much about the wrong part of the problem. Okay. Okay. So we're making a copy and then it's just going to be actually just 2 lists. Okay. And then we're going to do val current stones equals of long. And from there, it's going to be let's see. So blink count dot repeat. Or no, sorry, it's repeat blink count. And so for each blink, we're gonna do Yeah, I know what I want to do. Okay. So, current stones is going to be stone. If stone equals 0, then return at map 1. If stone.toString.size mod2 equals 0, then I'm going to return at map, and it's going to be list of what would be stone.toString dot substring 0 comma oh, I see what I'm doing wrong. Kotlin, pretty please. Okay, we get the length, and then it's going to be substring to length, comma, stone. Okay, and then what I'm gonna do is I'm just gonna flatten this after. So dot flat. I know this is a bit awkward, but it'll make sense. Um, what do I do with part 2? It's gonna be um none of the other rules apply. The old stone's number multiplied by 2024. Okay. If it's gonna be list of flatten why does it not like this? Oh, Why does it not like this? What? Long. But I'm doing a map. Like, why can't I just map the long to? Hang on. Yeah. I know that I'm tired, but I'm just confused as to why I wasn't allowed to do what I wanted to do there. Like, that's exactly what I'm doing though. Why does it not like this? Oh, duh. Okay, that now makes sense. Okay, so let's just do it 6 times, and then the other thing I'm going to do is I'm going to do print line current stones for debugging. Why? Why, God? Why? 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 Okay. I'm tired. I should not be doing this at all. Okay, so I'm passing in the right values. Ew. Right. Herpa-derpa-doo. Why? What? Change element parameter of list. Okay. I don't know at this point. Sorry, I'm out of it. I'm not like reading words right. Nothing is. Hmm. Crashing on 10. It's crashing on 10 specifically here. So hang on. Substring start, and I'm starting at. Oh, I'm an idiot. Wow. I am out of it. I really should probably be sleeping. After blinking once. Okay. So let's try 7 times, and let's do the initial arrangement of 22. All right, so let's try 25. I'm gonna guess this is gonna blow up to take up too much memory or something. No. Okay, it seems to work. Yeah, I know I'm not gonna be able to do it 75 times. I know I'm not gonna be able to do it 75. It's not. So what I'm gonna have to do is figure out some kind of pattern that's emerging. And that's tricky. I need to obviously get rid of these print statements as well. Um, it's obvious I'm not going to be able to do 75 because it's growing exponentially. So I'll let it run, but let's think about this. So we go from 2, 3, 4, 6. Nine, 13. The issue is I don't think I can just track the number of digits. And that's where it gets tricky because like here I multiply this number by 2024. But I noted, hang on, I'm noticing these numbers start to get smaller. And maybe that's the trick. Hmm. Let me think about this one. Because this one, like, to be clear, my code's running. It's just that this is exponential growth, and I'm probably going to run out of memory. Um, Especially if I'm streaming. So I want to think. So this is what I'd call the first like really honest to god like hard problem because I don't know how to solve it offhand. Um, so right, like if I'm just tracking the number of digits, right? Okay, I get 3, 2, but the problem is when I multiply this number, yeah, okay, out of memory, which is what I expected. So, oh, but wait a minute, the numbers don't interact. The numbers don't interact at all. Is this a dynamic programming problem? I think this is a dynamic programming problem. Maybe. Okay, I get it. I get it. I think I know what I want to do. The point is, these two numbers, like the stones never interact. It's not really a list. It's just this stone becomes this one, splits into these two, but now these two stones behave independently as stones. That's all they do. And so I'm doing a depth first search, effectively. Um, so I don't need to do this sort of map flatten thing. I can just say like, okay, so instead, instead of trying to track all of the stones at once, just do one stone at a time. And so this would be like 25 if I leave it there. And what I'm going to do is I'm just going to do the same input and I'm going to implement part 2 to do this type of searching approach. And it's just going to be fun part 2 helper is list and this is going to return a long, and it's going to be so for now let's do return 0, and this helper is going to take in a stone, a single stone long, and it's going to return a count, and that count is going to, oh, and it's also going to take in blinks remaining int. And what it's just going to do is if blinks remaining equals 0, if we have no blinks remaining, then we return 1 because we have one stone. From there, we just do, this is where we apply the rules, right? We get process stone, and it's, so this is where we're going to do else, so next val, so it's going to be process stone, otherwise, so we're otherwise going to return the process stone dot sum of part 2 helper it blinks remaining minus 1. And let's see if we get the same result this way. I don't know if this is a good idea for the net. We're going to find out. Oh, well, it would help if I call part 2 helper. And then it's going to be stones and blinks. And it's just going to do return stones dot sum of and it's going to be part 2 helper it blinks. And this is going to return a long, and this is going to return long, and this is going to return long. They all need to return longs. Why are you unhappy? What has made you so upset? Okay, same result. Okay, that works. It seems like it's faster as well. Let's swap them and see if it's still faster. It certainly uses less memory at any one time, and that's kind of the primary bottleneck that we have. Okay, and it is actually quite a bit faster than doing this list thing. So what I'm going to do is I'm just going to do part 2 for both. And then do 75. And let's see if this works. It's still probably going to be pretty slow. So if I can, what I'm going to then do is try to add some degree of memoization in here, because I think this is a dynamic programming problem now. Yep. All right. Let me stop this, and I'm just going to do some dynamic programming, which would just be um, would it help though? I don't think it would necessarily help. So if hash dot contains key stone to blinks remaining, I mean, this looks Fibonacci-esque. It's just the issue is, like, I don't think dynamic programming is actually the solution here. But let's try. Oh, it's dynamic programming. Okay, there we go. It is, in fact, the dynamic programming problem. Where is it? Personal times. Okay, yeah, part one, I blanked, but yeah, it's just dynamic programming. Yeah, it makes sense because I noticed we are seeing a lot of the same numbers sort of over and over. And so, yeah, I'm not surprised by that. So just all I'm doing there is just caching. And there we go. It's just memoization. That's all it is. Just good old fashioned, all American memoization. Well, it's two observations. One observation is the stones never interact, so we don't need to treat them like a list. We treat them like individual stones, and when they split, they shall nary meet again. That's observation one. Observation two is, and then use caching. So there we go. So yeah, my part one time was atrocious, and it was just because I was trying to think too far ahead for a long time, and then I was bad at writing code. But hey, I got DP pretty fast. Yay! Granted, technically, I'm not doing DP here in the truest sense. I'm doing memoization. If we're doing dynamic programming, I'd basically start from zero and build up a map and then apply that. Um, I I also just don't care. You know, there you go. Memoization is your friend. Um, okay, a 11. Yeah, so just to explain the cache here. The point is, and I think now that I look at the input, it makes sense. Let me look at my private leaderboards. Hey, I beat quite a few people. Still on part 2. Um, that's just one of the things I've learned. Like I was expecting something sort of LCD related. Um, so yeah, okay. So now we're gonna go to the problem because I want to point out a few things. First, like while this looks like a list, it's not. It's actually a tree. Is the better way to think about it. It's a tree, right? So then we get 253, we get 2000, 2024. And something I'm noticing is that basically this becomes sort of a generator now. We have 2024, right? And that splits into 20 and 24. And then the point is like, look, there's 2024 again, and there's 448, and there's a lot of twos and zeros. And so the point is we're repeating the same calculation multiple times. And so rather than continuing to repeat that calculation, we just do it once and save the result. And then anytime it asks us, hey, like what do we do here? You just return the memo, right? Um, and the point is, as you build it up over time, my guess is you just end up with a lot of sort of the same numbers getting repeated over and over. So like once I've solved, for instance, um 2020 or once I've solved like 2 with this is 6 blinks, right? So I would have 69 blinks left, 69 nice. 69 blinks left with 2. Well, okay, I do that calculation. Not fun, but I do it. That takes a lot of time. But now I just save that number because I repeat it here and I repeat it here and I repeat here. Like I don't actually calculate it every single time 2 comes up. I already know the answer for 2 for that many blinks remaining. So this is the input. The key is the stone's value mapped to the number of blinks stone's value paired with the number of blinks remaining, right? And then um, from there the actual answer long. So we're just caching. That's it. Good old fashioned caching. I always like these kind of problems actually. Because he gives you like the easy case. Easy meaning you can brute force it with pretty much any strategy, and then he gives you the case that actually makes you sort of think about like what could work here. So to explain why I was stuttering and getting tripped up early, let's look at this example. 125, 3 characters long, which means not an even number. So we multiply by 2024, which happens to be this, I guess. Which I'm not surprised by. But then we split because we went from 3 to 6. So you might think, okay, then we go from 3 to 6. Oh, hey, that's great. That means that when we multiply by 2024, we're adding 3 digits. Wrong, because we go from 3 to 7. And then we go from 7 to 1, 2, 3, 4, 5, 11. So we add 4 digits in these two cases. Do we? Wait. 3 to 7, we have 4 digits, and then no, we're only adding 3 digits. I miscounted. So sometimes we had 3 digits, sometimes we had 4. If we were multiplying by 1,000, this is actually a really easy problem because at that point I only need to keep track of how many digits I have. That's it. If it were like multiplying by 1,000, the real numbers become irrelevant. It's just the number of digits. But because we're multiplying by 2024 and we're counting digits in base 10, I can't cheat and like use that. I actually have to do math. I can also do what is it in Kotlin? It is so multiplying by this number. Like in Java, it would be shift 10. What is it? Shift left 10? Shift this value left by the bit count number of bits. Yeah. So that would be, let's see if I make sure I get the right results. Um, this ends in 8592. I did not get the right results. Okay, interesting. Oh, that's because I'm a fucking idiot because that's not 10, that's 11. No, I'm still getting the wrong results. Okay, now we're running into all kinds of silliness. I guess do I have the stone saved as a long? I do. How is that not equivalent to I'm curious about something now. Print line 5 times 120. This should be the same print line, and let me make these longs. This should be the same as it is. Hang on, how is... Oh, I'm an idiot. It's the power of 2 is 2048, not because it's 1024 times 2. I thought that I was I got caught up thinking this number was a power of 2. And I went down a rabbit hole thinking, can I do anything with the fact that this is a power of 2? Base conversion, something like that. And I came up with nothing. And that's because I'm an idiot, because 2024 is not a power of 2, because I'm an idiot. But never mind, you do need to just do the multiplication here. I'm trying to think of ways to improve this. I mean, it's fast, so like it's fast, so I don't really need to improve it. But I'm trying to think of like a sort of true DP because technically what I'm doing is sort of like a half-assed DP. It's not even really DP what I'm doing, but I'm trying to think like how I could do something like this is what it will look like in 1 and then 2 and then 3 and then 4 and then reuse that without I know what I can do. I would do something like this. And I'm gonna skip to 2 because if it's 1, I would just do the next step anyway. Let's try one. Okay, so if blinks remaining for I to that, or do I want to do decreasing? Yes, I want to do decreasing because and what I can do is if the cache contains stone to I, then I'm going to return um and it'd be cache, so get the cache value, and then it would be blinks remaining minus I. Oof, ooh, null pointer exception. Oh well, that yeah. Nope, that didn't help. You want to do a map? Okay, what I'm about to write is not good. Let me before I go down this road. Oh wait, I don't return. That's why. Oh, that is not right. That is not right. Yeah. Okay. This is my right answer. Let's commit. Okay, so from there, I'm going to do if for I in, and I want to go blinks remaining down to 1. And the point being, I can just skip ahead without processing. So if it contains key stone to, not blinks remaining, but stone to I, then I am going to return that cache. But I'm not returning it to, or I'm I'm instead going to return get stone count helper that value, and then comma blinks remaining minus. And I'm getting a vastly different result now. Why doesn't this work? Oh, no, that's right. I know this is a really bad idea, but I'm trying to figure out what's going on. The point is, we get how many stones it creates. Oh, wait, no, no, no. I see what's wrong. I see what's wrong. I see what's wrong. I'm confusing one problem for another. Because again, this gives me the this doesn't give me the stones. This gives me the number of stones. And the problem is that if I try doing this as a list, it's gonna foul things up. Yeah. Okay. Yeah. All right. That's yeah. Because the issue is like I could tell how many I could tell how many stones this stone goes into like 5 cents later. But then I'd also need to keep a map of what those stones are, which means calculating what those stones are, which means stepping through that anyway. The only way I can think to do that would be a bunch of back references and stuff, and I don't wanna. It's already fast enough for the problem that we're solving. But I see why I'm getting the wrong results. I'm just that's right. I mean, this is 55 milliseconds. Like, do I really need to optimize this? No. I know technically I'm not approaching DP the exact right way here, but it's good enough. All right, take care.